Yeah. So for today, our topic is satellite. Let's go to our milestone. So there are two milestones for today. First is types of satellite, and second is structure of satellite. Can you see?
Yes, Aditri. Where is the quiz yesterday?
No, I removed that. So yeah. So before starting, let me ask you a question. What is a satellite? Anyone? Yeah, Rifa.
A satellite is a celestial body that burrows around our planet.
Yes. So a satellite is an object that moves around a larger object. Now let's go to our first milestone. So, types of satellite. We can define a satellite by its inclination. First comes the equatorial orbit. Equatorial orbit means when the satellite revolves around the Earth along the equator. See, this yellow part is the equator. So, when the satellite revolves around the Earth by its equator, it is known as equatorial satellite. This.
Yeah.
So, over here, the inclination will be 0 degrees, as it is moving along the equator, because equator is in 0 degrees. So next comes our polar orbit. Polar orbit means when the satellite revolves around the Earth along the poles. See, North Pole, South Pole. So over here the inclination will be 90 degrees like this. You see? And then comes our inclined orbit. Inclined orbit means when the satellite revolves around the Earth in inclination of other than 0. In inclination of other than 0 means it will not revolve along the equator, but it will revolve anywhere else. Like it could be 1 degree, 2 degree, 3 degree, anything. Then it's by shape. By shape, first comes the circular orbit. Circular orbit means when from any point you take, the distance will be the same. Okay. Then comes the elliptical orbit. Elliptical orbit means when the shape of the orbit of Earth, of the orbit of satellite, is in the form of ellipse. And see, when the satellite will be near to Earth, it will move faster. But when it will be far from Earth, it will move slower. Then we can define it by attitude. So by attitude, first comes the low Earth orbit, LEO, which is about 160 to 2000 kilometers altitude, and it is mostly used for calling purposes. Like if I want to call someone in Russia, then because of LEO satellite, I will be able to do that. Then second comes the medium Earth orbit, which means MEO satellite. So over here, MEO satellite is about 5,000 to 10,000 kilometers altitude, and it is mostly used for GPS purposes, like the Google Maps and all. Then comes the geostationary orbit. Geostationary orbit is about 35,800 kilometers altitude, and it is used for weather reporting and etc. But the main thing about geostationary orbit is that if it is taking the information of India, then it will be taking for India only the whole time. It will move with the Earth, with the same speed the Earth is revolving. So every country has their own geostationary orbit. Then next is our structure of satellite. In structure of satellite, first comes the solar panels. Solar panels take the energy from the sun, which is the ultimate source in the space. Then comes the thruster. Thruster will contain all the mission points. Like we need to take care, like we need to, see what's going on in this part of the earth and all. Then comes the bus, which is the most important part. It gives shape and plus it protects the inner circuits of a satellite. Then comes the imager payload. Imager payload will take care of these three antennas, whether they are working or not. And bus will support imager payload by giving it shape and power which is collected from solar panels. Then comes the S-band antenna. Now, if the scientists want to, ask, they want that satellite give the information of the mission and all, like how the mission is going, share the pictures and all. Then they will send this message to S-band antenna. They send this message to S-band antenna. Now, for GPS antenna, if they want to change the location of the satellite, like they want, like the satellite is in the North Pole, they want it to move to the South Pole, then they will send this location identity to GPS antenna. For the location information, it will be sent for GPS antenna. Now the X-band antenna, it is fully different of S-band antenna. It will give the information back to Earth. Like they, click some photos. Now scientists are asking the photos. So X-band antenna will, you know, give it to the scientists. Now comes the camera. Camera will click the photos. Like now the scientist wants that go, and click the photos of Mount Everest. Then the camera is the one who will click the photos. Okay. Then comes the star tracker. Now while revolving, satellite finds a star which is a bit different, or you can say a new star. So the star tracker will take all the information of the star, like it will click some photos, plus it will take the location of the star and send it to the scientists so that they can research on it. Okay. Then comes the payload equipment. Payload equipment means,
Aditri, I need to go. I have another class.
okay, Subhani. Payload
Hi,
equipment.
everybody.
Bye. So payload equipment means that it will see whether the mission is going properly. Like the thruster will tell what is the mission, and the payload equipment will see whether all the components of a satellite are working on that mission. Got it, everyone? So that's it for today. Thank you.